Hey guys, here is a couple problems done out of the very first section, 6.1's homework. In the first section up here, in these problems, really what you're looking for is, if you read the section, an exponential function looks like ab to the x. So here's an a. This is not really b by itself, but the most important thing is b is supposed to be a number. So it's supposed to be a times some number to the x variable. And this, it's not an x variable. So this would not be an exponential function. This, though, a is 220, b is 1.06, and it is to the x. And so 15 is. And so that's the way to think about these problems up here in general. What I'm going to do for us is 18 and 20 right now. And so just watch, because each of them are different in their own right, and I want to kind of tell you why and get you to see that. So the first problem is 18. Well, here's what I do know. So I know that my function is supposed to be a times b to the x. And in this problem, I see that x is 0 and y is 6. And so if I say 6 equals a times b to the 0, then I've substituted the proper x and the proper y. Now, what I do know is anything to the 0 power is 1. And so then this is just 6 equals a. And I already have my a. And look, all I need to know is a and b, and I will have the entire function done. So I have half of it already taken care of. Now I'm going to use the other point and say, okay, well then 750 for y should equal a. Oh, but wait, I know a. It's 6. And then times b cubed. Now to solve this, we will divide both sides by 6. 750 divided by 6 is 125, equals b cubed. And if I cube root both sides, or I could do this, take both sides to the 1/3 power, because a power to a power you multiply, and 3 times 1/3 equals 1. So this side is b to the 1. And the cubed root of 125 is 5. So any way you slice it, you get b is 5. And now that I know a and b, like I said, I need a, I need b, so I have everything. So I think the answer should be a, which is 6, times b, which is 5, to the x power. So that's going to be our answer. And so I want to show you right now what that looks like. So I'm going to say 6 times 5 to the x, and there is the problem. And over here we had 2 points. We had the point 0, 6, and we had the point 3, 750. And if you look, the 0.06 there in green, it is on the graph. And if I zoom out, the 0.3, 750 also shows up on the graph right there. And so that is an exponential function that perfectly goes through those 2 points. And so what made this one easy, guys, is the fact that they gave me one of the points had a 0 for the x value. And since it had a 0 for the x value, and anything to the 0 is 1, I got for free what a is. So this here is always a if x is 0 or t is 0, whichever one. So I'm going to erase that then, and I will do the other problem because it's worked out slightly different. So the next problem I'm going to do is problem 20, and here's what we have for that. So once again, I know y is supposed to be a times b to the x. So using the first point, there's an x and there's a y. Then I'm going to say, okay, well, 3 halves should equal a times b to the negative 1 power. Okay. One thing to notice here is I have one equation, but I have two things I don't know. Whenever you have more things you don't know than equations, you'll never find an answer to that. And so this by itself has no solution. There's no single solution for that. So I'm going to have no choice but then to use my other point in the mix. So that one says y is 24. Okay, so 24 should be a times b to the x, and in this point x is 3. So I'm going to have ab cubed. Now I have a system, and I have two equations with two unknowns, and so this I have a better chance at solving. Except it's not like a linear system. It's not one where we can do just straight substitution or elimination, something like that. Because it's not an a plus a b, or an a minus a b, or a plus b, or any combination of that. That would be a linear system. But this is nonlinear because you have a negative 1 exponent and a 3 exponent, and so on and so forth. So what I'm going to do, and here's a spot where I really need you guys to think with me on this. What I'm going to do is build a ratio of these two. So I have two choices. I can either make it like this and this, but now hear me out on that. If I do ab to the negative 1 over ab cubed, you know negatives push down, so that would give me a over ab cubed times b to the 1. The a's would cancel, and that would give me 1 over b to the 4th. So I would have a 1 over b to the 4th equals something else. And the problem with having a 1 over b to the 4th is I would have to multiply both sides by b to the 4th and then do it the other way. So instead of doing it this way, I'm going to do it with this as the numerator and this as the denominator. Watch what happens. So I'm going to say, well, a times b cubed over a times b to the negative 1. If I build that fraction, I know what ab cubed is. ab cubed is 24. So if that's on the numerator on the left side, then I should put 24 in the numerator on the right side. Similarly, ab to the negative 1, I happen to know is 3/2. And so if ab to the negative 1 is on bottom, I can put a 3/2 on bottom or in the denominator on the other side. Here's the cool thing that happens about this and why this is how you want to proceed on these types of problems. What we get from this is the a's instantly drop out. And the b to the negative 1, we cooked it up so it came up top. And then you would have b cubed and b to the 1st. So b cubed times b to the 1st. This side is really 24 times 2/3. And if I kill the 3 with the 24, I get 8. And 8 times 2 is 16. So this side is 16. So it turns out to be b to the 4th is 16. So if I take the 4th root of both sides, then b is 2. Now remember, we're always going for a and b, and once we have them, we will have our exponential function. So I am right now halfway done, and that makes me happy. So now all we have to do is figure out what a is. Now to figure out a, I'm going to just reuse one of the points, and I can pick either one here, guys. I don't really want to use negatives and fractions if I don't have to. And thankfully, I don't have to if I choose not to. So I'm going to use this point only because to me, it seems like the numbers are nicer. So I have a y value of 24. That should equal a, okay, a times b. Oh, wait, I do know b now. B is 2. And then to the x, oh, x is 3 in this. Well, 2 cubes 8, so I get 24 is a times 8. And if I divide both sides by 8, I get a is 3. Once again, once I have a and b, which I do, I have the entire function. So now I know it should be y is a 3 times b 2 to the x. And let's check that out now. So if I delete that and zoom it back standard there to home, we said it's going to be 3 times 2 to the x power. And we have a couple points here, negative 1 comma 3 divided by 2. Whoops. And my other point is 3 comma 24. And hopefully very clear there. You can see that both of the points show up on that graph. And so there is the answer to this problem right here. So the answer to 18 we did, it was 6 times 5 to the x or whatever, and we did 22. 20 also, not 20, the number 22. In there, the difference was this had a point with 0 in it. So this one is going to be done like the first one, but these two are going to be done like the second one. And it's because, notice, neither one of the x values are 0 in there, and so you're going to have to do this type of thing. The other thing I want you to notice, and I really want you to do, is I always come back to Desmos and graph all the information that I have, because I want to see, am I actually correct? Does my graph actually go exactly through the points that I was requested to find a function for it to go through? And so if the function is in the proper form and it goes through the proper points, that has to be the correct answer. And so that's how you do these first problems, all right? I will be making a second video on the graphs, and then from there we will move into the properties of logarithms. All right, guys? Take care, and keep working, and keep watching for more to come, all right? Thanks. Bye.